On Monday, you took notes and watched the videos on simple equations, which are also known as one-step equations. And what we're going to do is do a quick review real quick and then move into the two-step equations. As you'll recall from the other day, looking at your notes and watching the video, you worked with one-step equations. One-step equations are also called simple equations. One of the things or concepts you watched had to do with inverse operations. Inverse operations are basically the opposites. So you don't need to copy this down. You should already have this down. We have what are called inverse operations. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the other way around, the inverse of division is multiplication. Whenever you're solving an equation of any kind, it doesn't matter if it's a one-step, a two-step, or what's called a multi-step equation. You're always trying to isolate the variable, trying to get rid of the variable. In this case, x plus 12 equals 32. Your goal or your job is to get rid of everything on the left-hand side of the equal sign except for the x. All right, as I was saying, you're always trying to solve for the variable. You're trying to isolate the variable. When I say isolate the variable, get it by itself. So I talked about the left-hand side of the equal sign and also the right-hand side. So when I say left and right, I'm referring to the side of the equal sign. So on this equation, we're trying to get x by itself. So that means on the left-hand side of the equation, we want to get rid of that 12. So that is a positive 12. We always want to cancel out. I don't know if I mentioned this yesterday, but when you add or subtract in an equation, for instance, this equation, you're adding x plus 12. You always want, when you add or subtract to cancel out, you always want it to equal 0. So what's going to make a positive 12 equal 0? Well, the inverse of a positive 12 is a negative 12. So I'll put a negative 12 there. Remember, it's like a seesaw. It's a balance. Everything has to balance out. So what you do to one side, you have to do the other side. So if I subtract 12 on the left side, I have to subtract 12 on the right side. 12 minus 12 is 0, so that cancels out. So what I do is I bring down the x. I'm going to keep my equal sign somewhat lined up. That's just for organizational purposes. So I subtract now 32 minus 12, and that gives you 20. So my value for x is x equaling 20. So one thing that I want to talk about is the property that was used. When I subtracted 12 from both sides, that is the subtraction property of equality. That is something that you need to make sure that you understand. The addition property of equality, subtraction property of equality, multiplication property of equality, and the division property of equality. All right? So, like I said, if you have questions as you're going through these videos, please raise your hands, pause the videos, call me over. I'll be glad to come over and help explain anything. And also, make sure you're pausing the videos as you need to copy the information down. Let me go back to the adding and subtracting, multiplying and dividing as far as the inverse operations. As I mentioned, when you add and subtract, you need to make sure that equals 0. So one of the things I want you to have is to go ahead and copy this part. When we use inverse operations, it has to equal 0. So this is the part right here you need to make sure you understand. When I look at this right-hand side over here, in this problem, you don't have to copy this problem down. I'm just highlighting it so you see it. When I subtract 12, it equals that 0. Now, multiplication and division. Multiplication and division works a little bit differently. It does not equal 0. It has to equal 1. So, if you'll copy that down. And what I'm going to do is I'm going to give you an example and show you why it equals 1. So let's take 5x equals 20. We can see that 5x equals 20 is multiplication because 5 times x side by side means multiplication. The inverse of multiplication is division. So I'm going to divide each side by the number that's always with the variable, just like we did when we did cross multiplying and dividing with proportions. We always divided by the number that's with the variable. So the 5 is the coefficient of x, so I divide by 5. 20 divided by 5 is 4. Now if you look at this left-hand side, this is the part that cancels out. What is 5 divided by 5? That's 1. So that cancels out. That's what I mean by it has to equal 1. So 1x, as we all know, 1x is the same as x. So instead of saying it equals 1x, I can just say that x equals 4. And I can go back into my problem. My original problem was 5x equals 20. Trying to make this one work out right. If I substitute the value of x is 4, 5 times 4 is 20, so that works out, and it's kind of messed up there, so I know 4 is the correct answer. Alright, so let's now get into what we're going to be starting today, which is two-step equations. So your central question, how is solving a two-step equation similar to solving a one-step equation? So, if you'll take a minute, copy this down, copy this central question down. And our topic is two-step equations. And what this is going to cover on digits is section 8.2 and 8.3. So we're going to knock out 2 sections of this. And like I said, pause and start the video as needed to copy your notes down. That's just the central question again. Alright, let's get into two-step equations. What steps do I follow to solve two-step equations? When you're solving equations, you're going to have a set of steps. When you get to Hannah, and probably this year, but definitely next year, in the 8th grade, you're going to have a list of steps you go through. You'll notice that this set of steps, we're going to build upon it. Step 1, we want to undo, as we did yesterday, addition and subtraction with each other. They're inverse operations. We then want to undo multiplication and division. They're inverse operations. And then step 3, always check your work with equations. Now, most of you are used to working order of operations where you have to do multiplication and division first and then adding and subtracting. With equations, you always get rid of the addition and subtraction first, so it's a little bit different. It's kind of going in the opposite form of, please excuse my dear Aunt Sally, order of operations. So the first thing we want to do is we want to undo or cancel out by using inverse operations with addition or subtraction. And then we move to the second step, undoing the multiplication or division using those inverse operations. Alright, so let's take an example. If we have 3x minus 8, you're going to notice here with this problem, it works a little bit differently than, or looks a little bit different than what you had yesterday. So, if we take this particular problem, 3x minus 8 equals 32, first thing I'm going to do is undo the addition or subtraction. So if you look at this problem, there is a minus 8. So I want to use the inverse operation for that particular part of the problem. So the inverse of a minus 8, or the opposite of a minus 8, is a plus 8. Remember, what I do on one side, I have to do on the other. So if I add on this left side, I'm going to have to add on the right side. A negative 8 and a positive 8, they're opposites, they cancel out, that equals 0. So those two things cancel out, so I'm going to drop down this 3x. And give me a minute, let me get this board straightened out for you. So I bring down the 3x. It'll turn black this time. Alright, so I now need to do the right side. Negative 32 plus 8. Some of you may need to write it, would look like this. And as you'll notice, going back to what we did at the beginning of the year, that 32 is negative, that 8 is positive. There's different signs, so when adding and subtracting with different signs, you subtract. 32 minus 8 is 24. With different signs, we take the sign of the bigger number. The 32 is bigger than the 8, so I take the negative. Alright, so that leaves us now with 3x equals negative 24. So, what I did is I took care of step 1. Now I'm going to move to step 2. And as you're going through these steps, if there's nothing to do in a particular step, just skip it. Go on to the next step. So step 2, we're going to undo the multiplication or division. Alright, we're now looking at this part of the problem. If you look at that, there's 3x equals negative 24. Is there any multiplication or division? If you notice, there's 3x, which means multiplication. So what I want to do is I want to do the opposite. I want to divide each side. So I'm going to divide each side by the 3 because it's with the x. The 2 3's on the left-hand side are going to cancel out. And that leaves the value of x. Then I'm going to divide negative 24 divided by 3. And if you have to, use this peace sign looking thing that we've talked about throughout the year so far. A negative divided by a positive leaves a negative. So that's going to give us a negative 8. Alright, so our answer is x equals -8. Before we move on though, let's talk about the steps we took. I have a -8, so I had to add 8 to both sides. So in that particular part of the problem, I use the addition property of equality. Like I said, you will have to identify these different properties. Then down here, I divided each side by 3. So we're on this part of the problem, I use the division property of equality. If it says equality, it's because you do the same thing on one side as you do the other. Everything has to remain equal. Alright, next step, I take care of step 2. Step 3, I want to check my work. So I have 3x minus 8 equals -32. I'm going to substitute that -8 in. And just a little word of note, whenever you substitute a number in for a variable, always put it in parentheses. You're going to learn that later on in the 8th grade, but definitely in the algebra. 3 times -8, a negative times a positive is negative, so that's -24 minus 8. -24 minus 8, those are two negative numbers, they're same signs, so I add, take the sign, keep the sign, so that's -32. And let's compare the two sides. Does -32 equal -32? Yes, it does, so I know that's correct, which means my answer of x equals -8 is correct. Now, I didn't highlight it as we went on, but I do want you to copy this down, please. So if you need to rewind the tape or the video so that you can copy this down as we go, please go ahead and do that. And like I said again, pause it as needed and then move on. All right, let's try these two problems. I have 4x plus 5 equals 13. First thing I'm going to do, I'm going to go through my steps. I'm going to take care of my addition and subtraction first. I'm going to take care of my multiplication and division second. And then the third thing I'm going to do is I'm going to check my work. Okay? So I have addition and subtraction in the problem, so I have a plus 5, so I'm going to do the opposite. I'm going to put a minus 5. What I do to the left side, I do the same thing to the right side. Remember, we're always getting rid of the numbers that are on the same side of the equal sign as the x. So I have to get rid of the addition first. 5 minus 5 is 0, so that cancels out. Bring my equal sign down. 13 minus 5 is 8. I'm going to drop down this 4x. So this part right here cancels out. So I've taken care of step 1. Step 2, take care of the multiplication and division. 4x represents 4 times x, so I'm going to do the inverse of that, which means I'm going to do the opposite, or the inverse, which is division. So I'm going to divide each side by 4 because that's the number of the variable. The 4's cancel out, so that leaves 8 divided by 4 equals 2. So my answer is 8 equals 2. Alright, now to go to my last step. I've got to check my work. So what I'm going to do is do 4x plus 5 equals 13. I'm going to substitute the 2 in. 4 times 2 is 8. 8 plus 5 equals 13. So the two sides are equal with each other. So that shows me that my answer is 2. So I've checked my work. Now I'm going to go ahead and highlight this so that you'll have everything that you need. So we'll copy this problem down. And then we're going to pause this video, stop this video, and then move on to the second video, and we'll pick up with the second problem right here.